This video consists of the determination of angle of prism using spectrometer, and here in this video we'll go through several steps, and the steps are listed here. The apparatus, this is the chapter 1. Chapter 2 we will discuss to find the Vernier constant or the VC, and chapter 3 will be the measurement part. Now let's go to the virtual lab. So here is my virtual lab. Here this is written as angle of prism using the spectrometer theory. This is the procedure, and this is the finally the simulator. So I will suggest to read all of you the theory from reputed books, and you can see this is the measurement of angle of prism A here, and this is given by this A equals to A1 plus A2 divided by 2, where this A1 and A2 are nothing but these two angles, and this 2A, that means the twice of the angle of prism, is nothing but the addition of this A1 and A2. Now I'm going to the second part, that means that after our chapter 1, that is the apparatus. If we go to the virtual lab, so go to the simulator. So this is my apparatus. You can see one is a collimator, there will be a collimator, and this is a telescope, and this is the prism table. This is the window 1, window 2, or you can name this is window 1 and window 2 for the vernier. And if you go through the setting of the focusing, now I will repeat it again, I just want to show you something about the apparatus. So this is my slit from where the light is coming. So we can switch on the light. You can see a light is coming from this portion and it is entering this portion, and through this we can see through this telescope this slit. Now we can adjust the slit width, and this is defocus, this is not in focusing mode, so we have to focus it. So we can use this slit focus option. So now my slit is focused. So this is the apparatus. You can see from the top of, this is the top view or the bird eye view. So this is the prism table, this is the window 1, vernier 1, and this is the window 2 or the vernier 2. So this is all about the apparatus. Now I'm going to chapter 2 to find the Vernier constant. So what is the purpose of this Vernier constant? So let's go back to the apparatus. So in this portion we have a main scale. This is the main scale reading, MSR, and this is the vernier scale reading, how to take the vernier scale reading. So suppose our value, while measuring the things, suppose our value is in between 50 and this one, or the 50.5, 150 and 150.5. so suppose our scale coincide with this part. So what is the exact value of this? Should I take 150 or 150.5? So there will be an error. To eliminate the error, we need a very least count, so that we can count a very least amount of measurement. So that's why this vernier scale is given. Now what is the vernier scale here? You can see this is from 0 to 30. Now you can see this is the 150. How many scales are actually equals to this 30 scales of vernier? Let us count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27. There are 27, and this is 30. So this 27 of the main scale covers 30 of the vernier scale. So what should be the Vernier constant? So yeah, so we have 30 vernier scale reading equals to 27 main scale reading. So let's calculate the Vernier constant. How to calculate that? So we have 30 Vernier scale reading. 30 VSR equals to 27 VSR MSR, or the main scale reading. And what did you mean by one main scale reading? Let's check. So this is 150, this is 151, this is 152, this is 153, and so on. So in between 151 and 150 there is a one graduation, so that must be 150.1, or sorry, 150.5. that means 0.5, that means half degree. So we have taken one main scale reading equals to half degree. Let's go to this. So this MSR, we have replaced this MSR equals to half degree. So 27 by 30 times half degree, so 1 VSR will be 27, means is 9 by 10 of half degree. So Vernier constant equals to 1 MSR minus 1 VSR. That is the difference between one main scale reading and the one Vernier scale reading. So we can measure up to this much of difference in the scale. So this is my MSR, and this is the VSR. We can measure this much distance, up to this much distance. So what is that much distance? Let us calculate. So this is, let's go to this. So one main scale reading minus one Vernier scale reading. So we have half degree, that is one main scale reading, minus 9 by 10, and whatever we got from the Vernier scale reading. We actually interpret this Vernier scale reading in terms of this main scale reading, so that the subtraction could be easy. So we got the Vernier constant as 0.05 degree. So this is the way how we calculate the Vernier constant for a Vernier scale. Now let's back to the spectrometer. Now here comes our focusing. So what we do actually, let's start from the start. Let's reset it. So when you go to the simulator, so first of all, when we go to the simulator, we can see this type of figure. So what does it mean? In case of a regular prism table or the spectrometer table, you have to focus your telescope for a distant object. So this is my distant object here in the simulator. There's a similar analogy between that. So we have to focus it, and after that we have to click the start button. So this is the switch on the light, and you can see the light is switched on. It is going through the collimator slit. This is my telescope. You can see through the telescope. Now let's make this slit with a little bit bigger. Let's focus the slit. So yes, this slit is focused. Now we have to make a zero adjustment for the table. This is now at 150. We have to make it for 0 and 180. So let's do it. This telescope is okay. This is a Vernier table. We have to make it 0 0. So we are moving it. You can see this is moving towards left, this Vernier scale, and the table is moving anti-clockwise. So it is coming to 0. Now the zero adjustment is completed. Now you can see there is no slit actually. This is basically there's a barrier in between that. So this is a prism where we are going to set the prism. So when we place the prism, you can see, so that this prism should, this edge should face the light. Okay, so light should fall on that face. This is the phase 1 and this is the phase 2. So we will assign this phase as phase 1 and this phase as a phase 2. Now let me tell you the steps how to do it. So the first step is the control. So we have the switch on of the light, so we have switched it on. Next we have focused it, the slider, the slit width, and we have placed this telescope exactly in line with the collimator. Now we have moved the vernier table so that it can be adjusted to 0 position for the vernier 1 and 180 position with 0 for the vernier 2, and we have placed the prism here, and there is another option is there, that's called remove prism. We can remove the prism. Now we are going to perform the experiment. So as we can see from the theory itself, let's go for the theory. So light is coming from the collimator and this is falling on this phase. You can say for us this is phase 2 and this is phase 1. So we can expect a reflected beam here from this part and a reflected beam from this part. So here we have the telescope. We will move the telescope from this direction to this direction and this direction to this direction. So we can get the reflected beam for both the reflection. Now I'm going to move this telescope. So this is the change angle. We will not touch this vernier table 0. We will only touch this telescope. So we'll going. Okay, so let me go to the position 1 first, phase 1. So this is our phase 1. Let's move it slightly so that we can get the reflected beam. Okay, so it is going apart, so let us use the fine angle. This is my fine angle tuning. Okay, so this is the thing, we are getting this value, so we have to calculate what is the value. So how to calculate it? So this 0 value is not exactly matching with this 300, so what we have to do, this is 300, so it must be 299. This is 299.5. So it just passed through 99, but it didn't touch exactly 300. So you have to find out the value where for the VSR. So how to find the VSR, vernier scale reading? To find the VSR, we have to look at the scale. We have to look at the graduation, where this vernier scale graduation or the vernier scale mark actually touching with any of this main scale reading. So you can see in our case, if we can see this 20 is almost touching this part, so we will take only this one. So our vernier scale reading should be this 20. For some reading, for the VSR vernier 2, you can see this is also touching this 20, so we can take this one. So let's take 20 for the vernier 1. So we have to put the value of the vernier 1 as 299.5, and this is the main scale reading, and for the vernier scale reading it should be at around 20. Yes, and you can also take I think 30 is also matching, so I think this 20 is okay. 20 is okay for this case, so we'll take this vernier scale reading as 20. So where to put it? Let's go back to your measurement. So this is phase 1, this is 299.5, this is your vernier 1, so this is your vernier, say 20. So total reading is main scale or the MSR, that is also in degree, so I have to mention it in degree, and this total is also in degree. So as this vernier 2, just copy and paste, and this one, okay, fine. This is my VSR is 20 for the vernier 1, and in this case we have to go for the vernier 2. What is the vernier 2 value? Vernier 2 value is, this is 120, this is 130, so this must be 129.5, and this is the 20, 129.5, take it 129.5, 129.5, this one, oh sorry, it's not 129, this is 119, this is 119.5, this is 20, and the main scale will be, this is the main scale, this is the vernier reading, this is the VSR 20 multiplied with the VC, and you know the VC value here 0.05 degree. So this is 20 times 0.05, 20 is the VSR and 0.05 is the VC. So you will get this VSR into VC, and you add this up with MSR, you will get the vernier readings. For this case, this is vernier 2 reading and this is the vernier 1 reading. So once you get, now this is the vernier 1, vernier 2, now you have to go for the phase 2. Now this is the phase 1, you have to move the telescope towards the phase 2, and to do that you have to go in this direction. So you can find the slate out here, the crosswire. Now you have to take the value for the vernier 1 and the vernier 2 for phase 2, and you have to write down the values for the same MSR reading, VSR reading, total reading. For vernier 2 MSR, VSR and the total, you will get the phase 2 value. Now you have to subtract these values from one phase to another. This is phase 1 to phase 2, F1 minus F2, which one is larger, you have to subtract it, and you will get the value of the total angle, this total F1 minus F2, this total F1 minus F2, and you have to just, to get the value, you have to just get the average. So what you will get the F1 minus F2 average value, and that is nothing but 2 theta. That is nothing but 2 theta, this one. If you go to the theory one, so this is my 2 theta value. This is the if we take this is as angle of prism A, so this might be not theta, through 2 theta, that might be, sometimes people say this is 2 theta, sometimes 2a. So this is my twice a, this is my f1 value, this is my f2 value, so f1 minus f2, that will be twice a. And if we divide this total f1 minus f2 value divided by 2, we will get the angle of prism. This angle of prism is total angle divided by 2. In the procedure section you can also see this is my condition, this is my 2 theta, this is the 2 theta value, this is the 2 theta value. So we will get the average, this plus this divided by 2, we will get the average value for the f1 minus f2. And again if we divide this average value by 2, we will get the angle of prism value. So let's have a look on that. For an example, suppose this is this difference between f1 and f2, that means this minus this. Suppose this is a1, and suppose this is suppose a1, this is suppose a2. Let's not write it here. So a1 minus a2. So our 2 theta slash 2 slash times slash theta equals to this a1 plus a2 value, add it up, whole divided by 2. So this is your 2 theta value, and if you want to get the angle of prism or the A equals to simply 2 theta by 2. That means whatever you get is equals to theta is equals to nothing but if you have got 2 slash theta divided by 2. That's it. So in this way you can find out the angle of prism. So this is all for today. If you find this video helpful, you please do like, share and subscribe our channel. Thank you for today.